Hey everyone, this is Tim from Native Instruments, and today I would like to walk you through how we went from Unsearchable to Unmissable and how we automated our keyword generation with BigQuery, Vertex AI, and Algolia. So, a few things about me. I'm Tim. I'm the Senior Director Web and Data Engineering at Native Instruments. And some of you might not know Native Instruments. So Native Instruments is everything that you see on this picture here. You see that there's a professional audio producing setup with the computer at its center. And this is actually how most of the modern music is now actually produced, with a computer at its center that does all the sound for you so that you do not need to record expensive instruments in the studio. So exactly what's running on this machine is what Native Instruments is doing. So let me give you an example here. So here you see arguably the world's best violins. So Stradivari violins built in the 17th and 18th century in Italy. In fact, in Cremona. And what you see here is the Auditorium Giovanni Averdi in Cremona, Italy, the original auditorium where these violins were first played and enjoyed by many people. So what we did is we went through a 32 microphone setup to capture every tonal nuance of this instrument. So this instrument is essentially captured every single tone so that you can use this instrument then as a virtual plugin to produce your sound. And this is a sound that was produced using exactly this plugin. Have a look. So now this is one example for exceptional violin sound. So the problem is that our catalog is not just violins. It's in fact over 1,000 of those instruments, and it's quite difficult to find your sound. So the issue that we encountered is that many of the searches for these instruments and these sounds were actually not yielding any really good results because describing your sound is actually quite difficult. Let me give you an example. Have a look at this. So I guess the question is, how would you describe this sound? How would you search for this if you would want to make this? Some things come to mind, maybe funk, maybe guitar. I can tell you what definitely did not come to mind. It's the actual name of the instrument that was used to produce it. The name of the virtual instrument is called Electric Mint. It has a standard description, the distinct and versatile sound of a 1960s solid USA-made electric guitar with 222 patterns. And what we quite fast discovered is that if we just index over these kind of very basic metadata, like the product name and the description, this actually does not really yield very good search results. So basically all the things that people might want to search for is not necessarily something that you can find in this metadata. So the idea that came to mind was, why don't we generate descriptive and helpful keywords with AI? And this is something that I would like to walk you through. So today we will craft a pipeline. We will actually craft a pipeline end to end. So let's start with a very basic data infrastructure blueprint. So this is something that we had, something that we already were building to run our analytics stack. So everything starts with data sources where product data is hosted. So most of our product data was hosted in our web shop system, our content management system, sometimes on a shared file system, but it's residing in some kind of database. So the first thing that we did is we copied this over into our data warehouse, because this is where we can do all joinery and combine all of this data. So in order now to join this together and to create good results and prepare an index, we apply some data transformations. And at the end, we use Apache Airflow to orchestrate all of this data flow so that at the very end, the index is synced to Algolia, or the index data is synced to Algolia and then used for search. Now, if you want to do AI keywords somewhere in this mix, we need to hijack the data transformation. This is where the magic needs to happen. This is where we need to do AI transformations. So how do we do this? Let's double click into the data transformations. So what we use is a tool called DBT, Data Build Tool. It essentially allows us to describe our transformations as SQL code with templating on top. And our data transformation is usually building on very, very defined, very standard steps. So the data usually comes in very raw. We call it source data. We then start to apply some business transformation, business logic. We then create a data mart, which are the kind of the data marts in the middle. And at the end, we might create a release data set, which is then used to power use cases like a search index. And if we want to hook in AI keyword generation, this is again where the magic needs to happen. So we need to somehow extend our transformation to build AI keyword generation into this mart data set. And this is where Vertex AI comes in. So Vertex AI and our BigQuery integration is where we found a good way to actually build AI keywords. So what I would like to do with you is to build an example here end to end. So by the end of this example, we will actually have created a full running pipeline with the steps needed to recreate this AI keyword generation. Let's go. We are now moving over to BigQuery, our data warehouse. And what you will see here is a very standard data warehouse structure that follows the pattern that I just described. So we have our source data. Let's assume this is exactly coming from our web shop. And we want to create a mart layer where the data transformation is applied, and then a release layer where we want to have our tables that we then sync over to Algolia. Let's look at our source data. This is very much like the structure that I described. It is a table with product IDs, names, categories, prices, brand descriptions, SKUs. And here's just mocked up example data with Native Instruments products, where you find a product, a category, a price, a brand, and a description. So let's take this as our source data like it would come from our web shop. What we now do is we add some data transformations. I'm going over to VS Code and use dbt. Again, data build tool, SQL-based transformations with some templating. And the first thing that I would like to do is I would like to do some very basic data cleanup. So what I have here is a prepared data transformation that just does not much more than just renaming a few things and preparing our data so that we have it structured and usable for downstream applications. So this is expressed as SQL. With dbt, I can essentially apply this and create a table in the data warehouse. For those of you that are familiar with infrastructure as code, with terraforming, this is essentially the same thing, but with tables in the data warehouse. So I just applied this very transformation. If I go back to our data warehouse, we will find, if I refresh the tables, we will find that there's now a new model called Mart Product Discovery Webshop Products, which is exactly applying our data transformation. For those of you that checked carefully, it's no longer called name, it's now called product name as a result of this transformation. All right, the next step is to apply AI keyword generation. And for this, we use the BigQuery integration of Vertex AI to essentially prompt our keywords. So I give you an example of a query here. So this is using a function called ML generate text, and all it does, it runs a prompt on a table. So in this case, I like in this very example, I don't have a table. I just want to show you that the prompt works. So if I run this, essentially the prompt, hi, how are you, creates a table with the result, hello, I'm doing well, thank you for asking. So this example, or this very function, we now want to use to exploit and create AI keywords. Going back to VS Code. So this is now how we exploit the keyword generation. So all we do is we loop over our webshop products that we just created, and we created a prompt that actually asks the model behind, which in this case is Gemini, to create these keywords for us. So the prompt is generate 15 keywords that can be used for text search on our website. The keywords should be descriptive and include competitor products, related instruments, artists, genres, movies, albums, and generally related terms that would make it easy to find the product. Output just the keywords separated by comma in a single line. So this prompt is now used to generate these keywords. If I apply this prompt with dbt, again, it creates a table in the background. The prompt that you're seeing, or the SQL statement that you're seeing, is essentially the description of the table that is now created in the background. So this creates a table in the background, takes a couple of seconds, just 10 or 12 seconds, I think, for these examples. We only have 10 products in our table. And if I now go back to our data warehouse and refresh the content one more time, you will find a new table called Product Discovery LLM Keywords, now having a new field LLM Keywords, which includes the keywords that we just created. And as you can see for this product, we move to the right, you will find keywords that we didn't have before. So these are synthetically generated through Vertex AI and now very descriptive of the things that we want to have for our full text search. As the final step to conclude our pipeline steps, so we also need to create a release table. So this release table is just renaming the SKU to object ID to make it more Algolia compatible. I'm also going to run this. And this table now creates our final table that is the index structure that we want to have all of our transformations in one place. So let me refresh this content one last time. In this release data set, I now have a ready-made table, which is exactly mirroring the structure of our index that we would like to use. And just for demonstration, I'm going to preview here again object ID, product name, descriptions, price, and our LLM keywords. So moving over to Algolia, I have an example project. It doesn't have any indices in it yet. So let me use the BigQuery connector to actually create this index. So this task is connected to this very table that we just created. And if I run this task, it takes a couple of seconds. I think it took 9 seconds before, so it takes a couple of seconds. And if I move over to my index again and refresh this page, we now have our product index. And this product index has all the attributes that we need to power a good search. As you can see here, we have all of these keywords that we just created using Vertex AI in our index as the property LLM keywords. All right, so I've shown you all the transformation steps necessary to go from raw source data, like it would come from our web shop, over to MAT data, where we apply the transformation, and we created the AI keywords and synced this over to Algolia into our index. So the magic, as you were seeing, is actually the prompt. So the prompt is actually quite simple. So this is the very prompt that we were using. So generate keywords, which is the action. We give some extra details, like we want to include competitor products, related instruments, artists, genres, movies, albums, and an output. Output just the keywords separated by commas in a single line to make it easy to parse this. And this very prompt not only works in English, of course, it also works in French. I mean, I don't understand French, unfortunately. But the good news is it also picks up the French context. So running this will not just translate over the same keywords, it might create different ones that are more applicable to French language. So the artists, genres, films, and albums might be more French than for the English language, which we found quite interesting. So now, as a result, the positive result, you can now search for this very product, Electric Mint, not just by putting in guitar. You can put in something like Stratocaster, Pulp Fiction, Jimi Hendrix, or surf rock. And this is something that allowed us to reduce our no result rate by a factor of 10. So we went from 20% no result rate down to 2. And this is a very good result alongside all of our other core metrics that improved. And with the steps that I was just showing you, I hope you can recreate this for your use case. And I would also want to thank you for attending here today. Make sure you also check out the other talk on solving the cold start problem and optimizing AI search with synthetic data, also at DevCon 25, either now or in the recording later. Thank you so much and talk to you soon.